Hello everyone and welcome to my channel. This channel is all about coding. Here you will see detailed explanations on data structures and algorithms. You will also learn how to solve coding interview questions by diving deep into the logic and intuition behind it. And before moving further, you might also want to click on the I button to see more LeetCode solutions. So let's get started. Today's question is from July LeetCoding Challenge Day 4 and it's called Ugly Number 2. In this video, we will discuss a method which is better than the DP solution in terms of both time and space. So the problem here is we are given an integer n and we need to find the nth ugly number. Now, what is an ugly number? So a number whose prime factors only include 2, 3 and 5 is an ugly number. For example, 1, 2, 3, 4, 5 or 12 or 10, etc. A straightforward solution you might think is to find prime factors of every number. And if we see a prime factor other than 2, 3 or 5, then we can skip this number as it would not be an ugly one. But this method would be very time consuming and you will end up exceeding the time limit as most of the numbers are not ugly. So most of our time will be gone while checking the prime factors of non-ugly numbers. So is there any better way? The answer is yes. According to question, an ugly number would look like this: 2 raised to power I times 3 raised to power j times 5 raised to power k, where I, j and k are non-negative integers. Now what we can do is, we can generate ugly numbers by putting values of I, j and k in this equation. We can do this simply by using 3 nested loops, each for 2 raised to power I, 3 raised to power j and 5 raised to power k. Now, because most of the elements are not ugly, the magnitude of an ugly number could be more than 1 billion. But the total ugly numbers generated would be less than 1690 as mentioned in the question. So what we are going to do is, we are going to generate ugly numbers till 10 billion just by putting values of I, j and k in this equation. We store them in a list. After that, we can sort the list and return the nth element. The magic will happen when we perform all this computation at a global level, and inside the main function we just return the nth element from the list. The beauty of this solution is we perform one time computation whose time complexity is on your screen. After that, for every n, we just return nth element from our list, which is a constant time operation. So we have a list in which we are going to store our ugly numbers. Then we define a variable called m, which is initialized to 10 billion, and we are going to generate all the ugly numbers which are less than or equal to m. Then you see we have 3 nested loops. I would be varying from 1 to m, and after each iteration we update I by multiplying it by 2. J would vary from I to m, and after each iteration j would be multiplied by 3. K is varying from j to m, and after each iteration we update k by multiplying it by 5. Let us now see how these 3 nested loops are working. So initially I is 1, therefore j would be 1, and as a result k would be initialized to 1. Now what we are going to do is, we are going to add k into our list, and then we are going to update k by multiplying it by 5. So 1 would be added to the list, k would now become 5. 5 would be added to the list, k would now become 25. So 25 would be added to the list, k would now become 125. So we add 125 to the list, and so on and so forth till k is less than or equal to m. After this innermost loop, we update j. So j now becomes 3 because previously j was 1. So now k would vary from 3 to m. Again we will repeat the same process. We add 3 to the list, k now becomes 15, so we add 15 to the list, then we will add 75 to the list, and so on and so forth till 10 billion. Now again we update j to 9 because previously j was 3. 3 times 3 is 9. K would now vary from j to m. It means k would go from 9 till 10 billion. Then we are going to repeat the same steps again. 9 will be added to the list. K would now become 9 times 5, which means 45. So we add 45 to the list, and so on and so forth. So I hope it's clear how these 3 loops are working. At the end, what we are going to do is, we are going to sort the list of ugly numbers. And inside our main function, we are just going to return the nth element from our list. This code would run very fast because we have done main computations or pre-computation outside the class at the global level. It means that these lines of code will get executed only when the program is loaded. After that, we can just call the method nth ugly number multiple times to know the answer. Let us now look at the time complexity of this solution. For this innermost loop, the time complexity would be big O of log base 5 m. Similarly, the time complexity for this loop would be big O of log base 3 m times log base 5 m. Similarly, for the outermost loop, the time complexity would be big O of log base 2 m times log base 3 m times log base 5 m. And we all know the time complexity required to sort a list. It is n log n. In our case, n would not be more than 1690. So the time complexity would be 1690 times log 1690. Now, whenever we call this method, we are just returning the nth element from the list, which is a constant time operation. So the total time complexity of this entire code is on your screen. If you like this video, please hit the like button and subscribe to my channel.